Alright, for part A on this problem, we're given this graph. This is the graph of f. But then we're given a function g that's defined as g of x equals the definite integral from negative 4 to x of f of t dt. We want to figure out what's g of negative 1, derivative of g of negative 1, and second derivative of g of negative 1. We want to find out what those are equal to or state that it does not exist. So it's possible it might not exist. Well, let's look at the first one. G of negative 1. We're just putting negative 1 in the place of x here. So we're going to have the definite integral from negative 4 to negative 1 of f of t dt. So that just means the area under the curve from negative 4 to negative 1. So we're just trying to find the area of this trapezoid. Is that area going to be positive or negative? Negative, because it's below the x-axis. Alright, so keep that in mind. We should end up with an answer that's negative. Formula for area of a trapezoid, we have 1/2 times base 1, which would be negative 3, plus base 2, which is negative 2, so that's where the negative part comes from, times the height is the distance between the bases, in this case would be 3. So we get negative 5 times 3 times 1/2, we get negative 15 halves, or negative 7.5. Right, next we want to figure out what's the derivative of g of negative 1. Well, let's look back at this equation. G of x equals this definite integral. If we were to take the derivative of both sides, well, on the left we just get derivative of g of x. What do we get over here if we take the derivative of the definite integral from a constant to x of f of t dt? Derivative of the antiderivative. They cancel each other out, right? This is another part of that fundamental theorem of calculus. We take the derivative of this from a constant to x of this function, we just get the function in terms of x, f of x. Remember, if it were like x squared up here, it would be f of x squared, but then we have to multiply by the derivative of x squared. It'd be like chain rule. But here, pretty simple. Derivative of g of x equals f of x. So the derivative of g of negative 1 is the same as f of negative 1, and we can just look at the graph to figure that out. If we put negative 1 into f, we get negative 2 out. Right? Not a lot of calculation there, it's just understanding what the derivative is. And then our last part, second derivative of g of negative 1, well, that's going to be the same as the derivative of f of negative 1. Right? If the first derivative of g equals f, then the second derivative of g would have to equal the first derivative of f. So what's the derivative of this graph? What's the slope of this graph at negative 1? Well, over here we have a slope of 1/3. Over here we have a slope of 2. Left-hand derivative, right-hand derivative, are they the same? No. So what does that tell us about the derivative at this point? Does not exist. And I would write the whole phrase out on the AP test just to be safe. You don't want to lose points. I don't know if they take points off for DNE, but it might look like 1. They did lose points, so just write out the whole term does not exist.